Hi, ladies and gentlemen. This is Project Fuel Cell Drone, and this is all my teammates. They are the mechanical, electrical, and control team leads. This is Min Pei Fen, Jin Ren Chen, and Zhu Hao Tao. So in the beginning, I will give a quick introduction of our project. So fuel cell battery is a new form of battery which uses the chemical reaction to produce electricity. The fuel cell uses the oxygen gas from the air and also the hydrogen gas to react with each other. In the end, they're going to produce the water and electricity. And you can see there's no any pollution going to pollute our environment, so it's a perfect clean energy to use. And also, the fuel cell battery have another characteristics, which is high energy density ratio. And then this is the main reason why we forming this project, because the high energy density ratio can provide our drone with a longer flight time and also a better performance. By comparing with the traditional lithium battery drone and the fuel cell battery drone, we can see the traditional lithium battery drone can only fly like 20 to 30 minutes. But the fuel cell drone, according to the other laboratory testing, it can fly between 1 hour to 2 hours, which is twice or 4 times of the traditional lithium battery drone. So next, we're going to introduce the goal, requirements, and the objective of our project. The first is quite clear. The goal, we're going to build a fuel cell battery powered drone, and also with different functions like carrying loads and also filming. So it brings us the requirements of our project. We're gonna design a drone ourselves. Could be powered by the fuel cell battery, and also it could be powered by the lithium battery also, because we're gonna compare with each other. And then goes to the function part. We're gonna make our drone carrying 5 pounds payload, and then test it with the video recording function. And then all these functions should under like 30 minutes flight time. And the last, we must control the temperature of fuel cell battery under 5 to 35 temperature degrees Celsius. And then last is the objective. We're gonna research. The reason why we're doing this project is we're trying to research about the fuel cell battery for the low powered device application. And also we're gonna learn how to DIY a drone ourselves. And the last is learning the construction materials and electrical components of our drone. Next, my team is gonna introduce the team structures.
Hi, my name is Zhu Hao Tao. I'm gonna talking about our organization. For this project, we have 3 sub-teams: electrical control, mechanical, and the secretary. They all have the different responsibility. For control and electrical team, their job was to do the trade study for all electrical components and circuit design. For mechanical team, their job was to do the structure design by using the SolidWorks and design which material we're gonna use. For secretary team, their main job was to do the document stuff and team communication. This is our timeline. Week 1 to 3, we had an introduction of our project. Assign each member to each team and give their own job for this project. Also, everyone start to do the research for drone operation. Week 4 to 6, mechanical team was working on the SolidWorks of structure and material simulation. For electrical and control team, they was working on the trade study for electrical components and circuit design. For secretary team, they were talking to each member in order to record their works and help them communicate with each other. Week 7 to 8, we initialize the UROP form of our fuel cell battery and do the last check for our design. Last 2 weeks, we upload all design and share to whole teams. Also, we made a schedule for next quarter, and the very last thing is we're making the poster and prepare for the presentation. Next part is mechanical part.
Hi, I'm Ming, and here's our final design for our fuel cell drone. And we have, as you can see in the picture, we have a gimbal and hydrogen tank. So this structure is designed specifically for drone which powered by fuel cell. And for our structure, we use a 4-layer structure, and we have 2 center plates and a center connector to form a sandwich structure. And these 3 things will work together to balance the weight of our drone. And for the material, we mainly use a carbon fiber plate, polycarbonate plate, and another aluminum. The advantage for our design is a simple, cheap, and reliable. And we also did some analysis for our design, and we did a SolidWorks simulation. We are testing the most extreme situation, which is applying 200 Newton force on the center point of our carbon fiber plate, and the result shows that the maximum deformation is about 9 millimeter. I think this is totally acceptable, which is because in our real situation, the carbon fiber plate gonna have a anodized aluminum connector to support it, and also have a 6 carbon fiber arm and a couple of connector to make the structure more reliable and stable. So the deformation in real situation gonna be much smaller. And we also did some calculation for different types of motors in the market. In the beginning of our design, the payload is 5 kilograms, but after our calculations, we found out our budget cannot afford this 5 kilogram payload, so we decided to reduce our payload to 5 pounds. So, and after calculations, we have two types of motors can achieve our requirements. And the next, I'm gonna introduce my teammates to introduce the electrical part.
Hi, my name is Jun Chen. I'm working for the electrical and the control team. Based on the data of mechanical team provided to us, we got two options of the motor. First one is the Sunny Sky, and the second one is the Tornado, and also the Populous. To meet the requirement of the electrical, the voltage and the capacity and the currents, we did a case study for our fuel cell drum. We finding out a few electrical components we need. First one is fire control and electrical speed control, and a LiPo battery, power distribution board, and cameras. After the case study, we make a circuit design with fuel cell battery and filming. As you can see on the left-hand side is the fuel cell module, which has a hydrogen tank and cooling filter, fuel cell stack, and DC-DC both, and the outside oxygen. The cooling filter controls the temperature of the fuel cell stack, and fuel cell stack is the place of the hydrogen and oxygen getting a chemical reaction to produce the electricity to goes to the DC-DC boost. DC-DC boost provide a stable voltage to power up the power distribution board. Power distribution board provide the voltage to power up the electrical speed control and the motor and the fire control and the camera. After we did the final design, we got a budget of our team, which are electrical components and mechanical components. The total price is around $1,200. Now is our team need to give the conclusion for our presentation.
So in the end, I'm gonna talk about the next step for the next quarter and then spring quarter 2020. So for the winter 2020 is manufacturing phase. We're mainly doing the manufacturing part, the drone parts and the electrical components. We're gonna build it up and then test it with function of carrying loads and then filming. So we're also gonna do the safety study because our drone needs to be safety. So that's also a task for the next quarter. And in the last quarter, we're gonna improve our drone structure to make our fuel cell could have a better efficiency. And also we're gonna improve the drone technology with different functions that could use in our fuel cell, because we're trying to make this fuel cell drone commercialized. And that's pretty much it for today's presentation. Thank you for listening.